Okay, when we left off, we were talking about voltage, resistance, and current in terms of a river and a dam. In this case, we're taking a look at a circuit. So voltage is going to be held in the battery. There's going to be a difference between the number of electrons that are on this side of the battery and this side of the battery. And those electrons, just like the dam, they want to flow through to the other side. And they do that by following this circuit. So the current is going to be carrying all those electrons across, and then it's going to hit something that is a resistor here. In a circuit that might be a light bulb, it's what's making it so that you can hear this video right now. A resistor has different functions. In this case, it's just taking energy from those electrons and turning it into something else. In this case, it's a YouTube video. Then it's going to be following along here, and all the electrons are going to flow around, going to the other end of the battery. Much like a river is going to be going around. It might hit some rocks, slow down a little bit, go around some more, hit more rocks. It's going to slow down the river some more, and then hit another one here. So that is how the comparison is. Ohm's law is going to be V equals IR. This is how we're going to calculate for current, voltage, and resistance. Voltage equals our current times our resistance. You can rearrange that to be current equals our voltage divided by our resistance, and then also our resistance equals our voltage divided by our current. So take a look at these problems and try and answer them using one of the three equations depending on what it asks for. So your first assignment is already uploaded. Make sure you take a look at that. Let me know if you have any questions. And we're going to jump right into magnetism. So magnetism in general is a very deep and mysterious concept. It's stuff that we're still studying and still figuring out, but it has a lot of similarities to electricity, which is why we're doing it both in the same week. So some differences. Magnetism is going to be dipole. So what that means is if you take a magnet, it's going to have a north and a south end. It's going to, if you take a look at this image in the bottom, a north end of a magnet is going to have these magnetic field lines going towards the south end. And that's the case for every single magnet. Unlike electricity, where it's monopole, that means that I can have a single negative charge here. I don't have to have another positive charge. They can exist by themselves. In a magnet, they can't. Even if you broke a magnet in half, you'd still have two different magnets, both with each a north and a south pole. And you could just keep on doing that and you'd still have two or more magnets. Some similarities is that they both have fields. Notice that there's a magnetic field. There's also an electric field. Magnetism and these magnetic fields are only able to be seen and observed with a moving charge. Charge is electricity. There has to be a moving electron or a proton in a magnetic field for us to observe it. Movement of electrons causes magnetic fields. So your phone, whatever you're watching this on your computer, it's actually creating a magnetic field. It's very weak, but it is there. The motion of the Earth's outer core is creating an iron or a magnetic field because the iron of the outer core is moving around. So magnetism can exist naturally, or it can be created using currents. If I have a current of electrons, it's going to create a magnetic field. So this is just saying that I have a current flow in a wire or a battery that's going to be creating a magnetic field, or they're just going to exist. A ferromagnet is a permanent magnet, one that you might just find, and then a paramagnet is a temporary magnet that becomes magnetic in the existence of another magnetic field. So if you put a magnet on your fridge temporarily becomes a magnet. If you take away that magnet from your fridge is no longer magnetic.